Welcome to my second video about airway pressure release ventilation. Today, we will address the main settings using the pressure time and flow time waveforms, which are essential to understand APRV. From the previous video, we know that APRV is a continuous positive airway pressure with an intermittent release phase. The application of CPAP for a prolonged time maintains alveolar recruitment. There is a time cycle release phase to a lower set of pressure for a short period of time. As we see in the flow time waveform, the release time must be short enough to prevent de-recruitment. This is different than other modes of mechanical ventilation where the rule of thumb is to adjust adequate expiratory time to the end expiratory flow reaching zero. This is not achieved in APRV, resulting in O2 PEEP, which is essential to prevent de-recruitment. APRV is superior to other conventional modes in allowing spontaneous breathing at any time regardless of the ventilator cycle. Therefore, two groups of settings to consider: pressure and time settings. Two pressure settings: high pressure and low pressure. Two time settings: the time for high pressure and the time for low pressure or the release time. Tube compensation must be turned on to support spontaneous breathing. APRV has different names depend on manufacturer's choice of terminology and copyrights. Let's discuss the settings in details. P high. P high ideally keep below 30. Initially, if you are switching from volume-controlled ventilation, set P high equal to plateau pressure, or equal to peak pressure if you are switching from pressure-controlled ventilation. A good starting level would be 25. Increasing P high if the patient is still hypoxic or hypercapnic. We reduce P high if the patient is ready for weaning. P low. Keep at 0 to optimize expiratory flow. The large delta pressure allows for tidal ventilation. We might need to go up if tidal volume is high and the patient is not suitable for weaning. Till now, it's a straightforward settings. Perhaps this is not exactly how it looks when it comes to the time settings. The whole respiratory cycle includes both the time high and the time low. So, let's assume that ventilator is giving 12 cycles every minute. We need then to divide 60 seconds by 12, which will give us a total cycle time of 5 seconds. If you set a T low at 0.5 seconds, the T high will be 4.5 seconds. The respiratory cycle settings are different between manufacturers, where the T high is based on the respiratory frequency and T low settings. In some ventilator, you set T high and T low. In others, you set respiratory frequency and T low. T high. T high is the main driver of the release frequency. Initially, a frequency of 8 to 12 per minute is reasonable. This will give T high between 4.5 to 6.5 seconds. A higher frequency might be needed if the patient is not breathing spontaneously or a high CO2 at the beginning. As patient wean off ventilator support, the frequency can be decreased. T-low. T-low is the trickest parameter that require ongoing attention if the lung physiology changes. Set to 0.5 seconds initially. Adjust by comparing the end expiratory flow rate to the peak expiratory flow rate. We tend to rely on the evaluation of expiratory flow waveform. The usual target is an end expiratory flow rate between 50 to 75% the peak expiratory flow rate. If you set inadequate T-low, this will tend to increase the end expiratory flow rate more than 75%, causing very small release breath, leading to ineffective ventilation and high CO2. If you set excessive T-low, this will decrease the end expiratory flow rate less than 50%, causing very large release breath and de-recruitment. This suggests that APRV is not functioning in a lung protective manner. In summary, we set APRV as P high equal to plateau pressure up to 30, P low set to 0. Set frequency between 8 and 12. T low set 2.5 seconds initially. Adjust to achieve an end expiratory flow equal to 75% of the peak expiratory flow rate. FiO2 start high, titrate down rapidly based on oxygen saturation. Tube compensation must be turned on to support spontaneous breathing. Thank you for watching my video and see you next video. Goodbye.